Okay, lesson 8.7, solving quadratic equations by using square roots. Our last two lessons, solving quadratic equations, we learned how to solve by graphing. And remember, the solution is where it crosses the x-axis. And then we learned how to solve quadratic equations by factoring. Okay, so solving quadratic equations by using square roots. Okay, let's review. If I have 3 times 3, that's also known as 3 squared, which gives me 9. Well, if I take the square root of 9, I'm going to get the main base, which is 3. Okay. Every square root has a positive and negative solution, because positive 3 times positive 3 will give me 9. Also, negative 3 times negative 3 will also give me 9. Okay, so when we're taking the square root of 9, we're going to say it has a positive and a negative, which is going to be positive negative 3. The two solutions would be positive 3 and negative 3. And this is just a short little symbol that you can use. Okay. The square root property states that to solve a quadratic equation in the form x squared equals a, take the square root of both sides. Okay, so in other words, you're going to take the square root of both sides. When you take the square root of x squared, that leaves you with just x. And then we were going to have plus or minus the square root of a. Okay. Using numbers, if I have x squared equals 15 and I want to solve for x, I have to take the square root of each side. Okay? Therefore, the square root of x squared is going to give me x. So x is going to be plus or minus the square root of 15. Let me show you something on your calculator. Okay, I'm going to zoom in. First of all, to find square root, you're going to go second, and here's your square root symbol. Okay, so second, square root, and let's say we want to take the square root of 36. Enter and we get 6. Okay, the way that I want to show you is to get rid of a squared. To get rid of the squared, you square root. It's an inverse operation. If you look on your calculator, here you have your x squared, but right above it in blue you have your square root symbol. Okay, that's because these are inverse operations. So in your head, think about it. If you want to get rid of the squared, you have to take the square root. Okay, they are inverse operations. Alright, example 1 says to solve using square roots. Okay, so let's look. I have x squared equals 16. I want to solve for x. Therefore, I have to get rid of this squared. I have to square root each side. So x is going to equal plus or minus the square root of 16. Well, what is the square root of 16? So x is going to equal plus or minus 4. So our two solutions are 4 and negative 4. Okay? Because 4 times 4 gives me 16, and negative 4 times negative 4 also gives me 16. Alright, look at B. I have x squared equals negative 4. How do I solve for x? Well, I have to take the square root of each side. But you cannot, the square root of x squared would be x, but you cannot take the square root of a negative number. It's not going to work, because there is not any single number that when it is squared will give you negative 4. Because the only way you're going to get negative 4 when you multiply is positive 1, negative 4, or negative 1, positive 4. Or you could take positive 2 times negative 2. It's not a perfect square. Because if I take 2 times 2, I get positive 4. If I take negative 2 times negative 2, I still get positive 4. There is not any perfect square that's going to give me a negative number. So we're going to say that this is no solution. You cannot take the square root of a negative number. Just remember that. Up to this point, our squared has been isolated. In other words, I've had x squared equals 16. My squared was isolated onto one side. It may be necessary to isolate the squared part before you can solve it. And you're going to isolate by using inverse operations. So let's look at example 2 on A. I want to isolate this x squared. I'm going to cover it up. That means I want to move this positive 5. Well, if I'm adding 5, I know I'm going to subtract 5 to move it. Okay. So I'm going to bring down my x squared, and 5's cancel out, equals 5 minus 5 is 0. So now to solve for x, get rid of this squared, I have to square root each side. So I'm going to have x equals the square root of 0, so x equals 0. Let's look at B. Again, I want to isolate the x squared, so the first thing I'm going to do is add 25 to each side. So I'm going to have 4x squared equals 25. I still do not have the x squared isolated yet, so if I'm multiplying by 4, I'm going to divide by 4 on each side. So I get x squared equals 25 over 4. Okay, well, to get rid of the squared, because I want to solve for just x, I have to square root each side. So that's going to leave me with x equals plus or minus, what is the square root of 25? 5. What is the square root of 4? 2. So my two solutions are positive 5 halves and negative 5 halves. Okay, look at C. Yes, the squared's isolated on this one. Although we have these items in parentheses, remember parentheses keeps everything as a group. That means it is one thing. So, to get rid of this squared, I'm going to have to square root each side. So, getting rid of the squared leaves me with x plus 2 equals plus or minus the square root of 9. So, x plus 2 equals plus or minus, what is the square root of 9? 3. I still don't have x by itself, so I'm going to have to break this into two different equations to solve. First equation, I'm going to have x plus 2 equals positive 3, or I'm going to have x plus 2 equals negative 3. Now I'm just going to solve for x on each side, so I'm going to subtract 2, so x equals 1, or I'm going to subtract 2, x can equal negative 5. There's my two solutions. And you could check this by plugging in. My equation started off as x plus 2 squared equals 9. Well, let's say x is 1. So I'm going to have 1 plus 2 squared. Does that equal 9? Yes, 3 squared equals 9. How about when x is negative 5? Let's plug it in to our original equation. Negative 5 plus 2 squared. Does that equal 9? Negative 3 squared does equal 9, so these are two correct solutions. Okay, it says when solving quadratic equations by using square roots, you may need to find the square root of a number that is not a perfect square. In this case, the answer is irrational. It's irrational because you're probably going to get a decimal, kind of like the square root of 15. We get 3.87298 and just keeps going. It's irrational because it's a decimal. It's not a perfect square. Okay? But it says you can approximate the solutions. Approximate means to round it. If I told you to round this to the nearest tenth, you know it would be approximately 3.9. By the way, this little squiggly line that looks like a squiggly equal sign means approximately. It's an estimation, it's an approximation. So example 3. Solve 0 equals negative 2x squared plus 80. Well, the first thing is I want to isolate my x squared. So in this case, I'm going to have to subtract 80 from each side. So I'm going to have negative 80 equals negative 2x squared. Okay. My x squared is still not isolated. I'm going to have to divide by negative 2 on each side. So I get x squared equals 40. So x is going to equal plus or minus the square root of 40. Well, square root of 40 is not a perfect square. It's a decimal. Okay. In this case, I want you to round to the hundredths. So what is the square root of 40? X is going to be approximately plus or minus 6.32. We get 6.324555532, but I'll send around to the nearest hundredths. Here's your hundredths place. So your solutions are positive 6.32 and negative 6.32. In example 4 is a career application. It says you can use square roots by learning how much fencing to buy for a pet zoo. I can see architects using this quite a bit when they're designing. Grab my iPad right quick. Y'all should be looking at your iPad as well. Chapter 8, Lesson 7, application problem. Okay, it says, a zookeeper is buying fencing to enclose a pen at the zoo. The pen is in an isosceles right triangle. Now, they drew you a diagram, and I'm going to redraw it here. Isosceles right triangle means we have two congruent sides. So these two sides here are going to be congruent. Okay? It's a right triangle because it has a 90-degree angle. It says there is already a fence. There is already a fence on the side that borders a path. So there's already a fence right here on this side. I don't have to worry about buying fencing for here because there's already a fence. Okay? I'm trying to find how much fencing I need for both of these sides. The area of the pen will be 4,500 square feet. Well, this is a right triangle. How do you find area of a triangle? Area is 1/2 base times height. Okay? So the area of this triangle says that the area of the pen is 4,500, so I have 4,500 equals 1/2 base times height. Well, what is my base and my height? I need to know those values to be able to solve this. Your height is your perpendicular distance. That means it forms a right angle. You're going to want to remember that for geometry. Your height is always a perpendicular. It forms a right angle. So in this case, I could say my height is x. My base is x. So I'm going to plug in x for my b and my h. So I'm going to have 4,500 equals 1/2 times x times x. Well, what is x times x? We have 4,500 equals 1/2 times x squared. Okay, well, to solve for x, I need to isolate the square, so I want to get rid of this 1/2. Remember, we can multiply by its reciprocal on both sides. So I'm going to multiply by 2 on each side. And that's going to get rid of that fraction. So I'm going to have 9,000 equals x squared. Okay. Well, now I've isolated my x squared. How do I get rid of the square just to find x? Okay, well, I have to square root each side. The square root of 9,000 is approximately 94.868. We'll round to the nearest thousandths. It says the zookeeper can buy the fencing in whole feet only. Well, if this side here is 94.868, and I can only buy fencing in whole numbers only, I'm going to have to buy 95 feet. So if this side's x and this side's x, this one's going to be 95, this one's going to be 95. That's how much fencing I need to buy. 95 plus 95 gives me 190 feet of fencing. Okay, and that's it for today's lesson, solving quadratic equations by using square roots.